In this video, we're going to discuss inference rules. We have talked about various things about AI, and one of the most important ones, very commonly used, are inference rules. So, what are these? These are templates for generating, deducing, inferring valid arguments. Okay, so inference rules. The word inference means to deduce information based on certain information that you already have. So these rules are applied to derive proofs in artificial intelligence, and the proof itself is like a sequence of the conclusion that leads to a desired goal, right? A sequence. Remember, we spoke about let's say search. So there are a sequence of steps that you take you to the goal, and likewise here. In inference rules, the implication among the connectives plays an important role. Once again, the same thing. The implication meaning there are certain things. If it is raining, you perform some action. So this is the implication of something that's happening. So it's a sequence of connectives, and that plays an important role. Some of the terminologies, implication, for instance, it is one of the logical connectives which can be represented, for example, P, some statement or idea, concept, P implies Q. Okay, so this means that if there's something called P which can represent a basic concept, and if that is true, then a corresponding another concept, Q, is also true. And it's like a Boolean expression called P implies Q. The converse of this, the converse of implication, which means the right hand side proposition, which was Q, goes to the left hand side and vice versa. So it can be written as Q implies P, right? Inverse. The negation implication is called inverse, which means not of P. P means yes, not P means the opposite of P. So we can say if P implies Q, meaning if P is true, then Q is also true. You can also say the inverse of this, which means not P implies not Q. That's the inverse. The couple of types of these inference rules. Modus ponens, that's an old name, just remember this. Modus ponens is one of the most important rules of inference, and it states that if P is true, which means P implies Q is true, then we can infer that Q will always be true. Q must be true, and there's a certain representation for that. Okay, which says, if you look at the diagram as well, if P is Q, as you can see on the low side, P implies Q, and P, therefore Q is also true. Right. So let's take an example. A statement: if I'm sleepy, then I go to bed. Right. So it's like saying, if P is true, if you are sleepy, then Q is true. You will go to bed. You want to go to bed. Okay. Another statement: I am sleepy, which means P itself. Conclusion: I go to bed, which is Q. So said in different format, but meaning the same thing. Anything that is true and by implication something else is true, rather than saying it will be true, it must be true. That's what it is. And then there are ways of proving this through truth tables and so forth. The other types are called modus tollens. The rule which states that if P implies Q is true and not Q is also true, right? P implies Q first, meaning the second one, and the second one is not true, then by implication, okay, not of P will also be true, because they are closely associated. One depends on the other. So if we don't know about P, but we know about Q, and we know that's not true, therefore we can say that P is also not true. Right. Take another statement. If I am sleepy, then I go to bed, right? P implies Q. Now, another one. I do not go to sleep, right? I do not go to sleep. What does it imply? That I'm not sleepy, right? So that's what it means. The modus tollens part of that. Right. This basically explains a little bit about some of these rules. The importance of these rules is that, by creating certain statements initially, you then infer new information. And if you look back in what we have discussed so far previously as well, now we are in a much stronger position that we can actually relate normal things that we talk about every day, of, as I said, in which the human beings are very good at. So we can represent those statements as true and false, of course, and then we can build up based on that logic, on that deduction, on that. And that is where the fundamental thing about reasoning in artificial intelligence comes into play. Okay, and of course, as I said, these can be are provable using simple truth tables, as we are aware. So this is all about this. We'll come back with a next video. Hope you liked it. Thank you very much.